Alright guys, today we are going to look at some notes for solving multi-step equations. So you have done solving one-step and two-step equations where you had to get the variable by itself and solve for a variable. We're going to look at something that is an example of more than two-step equations. When you see an equation and there's just more than two steps, we're going to call it multi-step. So here's what the page is looking like in your notes. We're actually going to skip to the next page where it says example 2 just to start, and we're going to come back to that first page in a minute. So let me show you one example of what a multi-step equation could look like. We've got this guy right here, 5x minus 16 minus 8x equals 23. Here's our equal sign. I'm just going to draw in my line right there. And when we've been solving equations in the past, normally we've been trying to get the x by itself, and we would get rid of the adding subtracting first because it comes last in the order of operations, so we're going to undo it first. But this is a little bit different because in the past we've always only seen x in one place. And right here we've got an x in two different places right here. We've got a 5x and a minus 8x. So before we're ready to get rid of anything, we can actually simplify this side right here. And I know you've practiced combining like terms and doing the distributive property sometimes to simplify. What we're going to look at today is, can you simplify the left side or the right side of an equation before you start to solve it? So here, for us to simplify this, I'm going to change this to adding the opposite and adding the opposite, plus a negative, so that I can look at actually combining these x's together, combining the like terms. 5x plus negative 8x. That's 5 plus negative 8, negative 3x. And you can leave it as 16 minus 16 or plus negative 16. It's the same thing. All right. Now, at this point, this is just a regular two-step equation. We've got an x we're trying to get by itself. We've got that times negative 3 that's going to have to go, and the minus 16 that's going to have to go, or a plus negative 16, either way. So now you're ready to just do what we've always been doing with two-step equations. How do you get rid of that minus 16? We're going to add 16, and we don't need all these extra boxes right here. We could just do it like this, plus 16 plus 16. Because minus 16 plus 16 goes away, and whatever we do on one side, we have to do to the other. So let's bring down what's left now. Over here, we got rid of the minus 16, so all that's left is negative 3x equals 23 plus 16 gives us 39. And now we've got this one-step equation. We need to get rid of negative 3 times, so we're going to divide by negative 3, divide by negative 3. Negative 3 divided by negative 3 is just 1, goes away, and you get x equals positive divided by a negative is a negative 13. That's what we believe our solution is. Now we're going to check it. We're going to go back over here and let's do a check off to the side. We're going to plug in x into the original equation. Now this time it's different because we see it in two different places. We see an x here and an x here, so we need to plug in an x to both of those. Here's what it's going to look like. 5 times negative 13, it was originally minus 16, minus 8 times negative 13. Does that equal 23? That looks like a pretty long statement right there. I need to do my order of operations when I'm just trying to simplify this. So let's go ahead and do some multiplication. I can do this in my head, but I'm going to bring my calculator in just to make sure, especially because this is a check. 5 times 13, negative would be negative 65, minus 16, minus, and I've got 8 times 13 negative is going to be a negative 104. So careful here because that was a minus, and now this is minus a negative right there. So minus a negative is really like plus a positive. Let's see, now since that's all adding, subtracting, I can just do this all at once. 65 negative minus 16 plus 104, does that give us 23? Yes, so 23 equals 23. And we're done. So the check looks a little bit longer, but it's really still just kind of 3 lines of plugging it in, making sure it works. So all that we are doing differently right now is looking at the equation and seeing if we can simplify it first before we solve it. So let's just look at these guys right here. Can you see, how about example 2? That looks a little bit lighter. Maybe we can see that a little bit better in this guided practice. Can you look at that and see, here's our equal sign. Are there things we can do to simplify either side? The 6 is just a 6. It's going to stay. But can we simplify anything over here? Yeah, we can combine those m's together. They're like terms. So I'm going to look at this minus 2m as a plus negative. M plus negative 2m. How many m's does that make? This is like 1m. So 1 plus negative 2 takes you down to negative 1m. We still have that plus 15. You still have equals 6. Can you take a minute and just solve that right now on your own? And then you can watch the video again. Okay, so we are going to do this two-step equation. We get rid of the adding, subtracting first. Minus 15 on both sides to get rid of that plus 15. We bring down what's left, which is negative 1m equals, and what's 6 minus 15? Negative 9. Now, we don't care what negative 1m is. We want to get rid of that negative 1 times. So we're going to divide by negative 1. And I get m equals a positive 9. Now let's plug that back in and check it. I'm going to use this space here since I'm not going to do this example right now in the notes. So I'm going to plug it back in anytime I see an m. M plus, so it's 9 plus 15. It was minus 2 times 9. Does that equal 6? Okay, I've got to be really careful to make sure I do all my multiplying first here. So 9 plus 15 minus 18. Does that equal 6? And now here's my calculator. I'm just going to make sure 9 plus 15 minus 18 gives me 6. Because it was all adding, subtracting. I can do that all together in the calculator left to right. Okay, so there's an example of multi-step equations where you had to combine the like terms first. Let's look at example 3. This is another one where you've got to simplify on one side, but the simplifying looks a little bit different. This simplifying looks like something that we would have done before using the distributive property. So if you take a look at this, let's see, can we do something to get rid of these parentheses right here so that then we can combine this n and this n? Remember, we can't combine them yet because that parenthesis is in the way, and that's multiplication. So I'm going to change this minus to adding the opposite right there. And we're going to do distributive property, negative 3 times n plus negative 3 times 1. That 10n just hangs out in front right now. So I'm just going to write it out, negative 3 times n plus negative 3 times 1. That's our distributive property. And now I can simplify. Let's see. Negative 3 times 1 is just going to be negative 3, right? So can I combine these like terms too? Can we just do that all in one step here? What's 10n plus negative 3n? That's going to be positive 7n. And this was just a negative 3. So I did the distributive property. I combined like terms. And now I'm ready. I just have a regular old two-step equation right here. And that's something that you've seen before. So now we're ready to solve it. We've simplified everything. I can't combine those. They're not like terms. I can't simplify anything over here. Once I've simplified everything, I'm ready to solve. I'm ready to actually do something to both sides of the equation. So I need to get rid of this negative 3. That's got to go. So to get rid of negative 3 to make it 0, I add 3. I'm not going to use their boxes here. I'm just going to do this. Plus 3 plus 3. Negative 3 plus 3, bye-bye. Bring down 7n equals, and negative 24 plus 3, careful here, negative 21. Now to get rid of 7 times, divide both sides by 7. And we get n equals a negative divided by a positive is a negative. Okay, so we think it's negative 3. Let's do the check. Let's plug it in. Anytime we see an n up there, let's go put that in and make sure we didn't make a silly mistake along the way. So I'm going to do the check right over here. 10 times, I think n is negative 3. And they had a minus or a plus a negative. 3 times, and then negative 3 plus 1. We want to know, does that equal 24? Now, here's the thing that some people get caught on, guys. They see that right there, and they think, oh, I need to do the distributive property because that's what I did in the problem. But in reality, there's no variables. we can actually just do negative 3 plus 1 and do the order of operations. Do what's in the parentheses first, and then you won't have a distributive property here. So that's going to be a negative 2 in the parentheses, and then everything else is in the same if I just stays the same. If I do what was in the parentheses first, it was a minus right there. After parentheses, there's no exponent, so I can do multiplying, dividing. I can multiply these, multiply these. This would be negative 30 minus, what's 3 times negative 2? Negative 6. And minus a negative becomes plus a positive. So let's just make sure. 30 negative plus 6 gives me negative 24. Awesome. So we didn't make any silly mistakes along the way. Now I am 100% sure that negative 3 is the solution. That's what makes that equation true, what makes it work. Okay, so let's look and do another example over here. Let's just do one more with the distributive property. How about this 5 in the middle here? So I'm looking at this equation, and I need to ask myself, can I simplify it before I'm ready to solve? Well, sure, we can get rid of these parentheses with a distributive property right there. So I'm going to be distributing these guys, 5 times 3 plus 5 times, I'm going to be really careful, I'm going to make this plus a negative a. So here's what it's going to look like when I write my distributive property. This a just hangs out. It's just an a out in front. Plus, here's my distributive, 5 times 3 plus 5 times negative a. You could put a time sign there if you want. I just did a parenthesis to mean times. And that equals 11. All right. So now I need to finish my multiplying before I can do any adding of like terms. A plus 15 plus 5 times negative a. A positive times a negative is a negative 5a equals 11. Okay, no more distributive property. So now I'm ready to continue simplifying by combining some like terms. This a and this a. 1a plus negative 5a is going to bring you up to only negative 4a's. Plus 15 still equals 11. And now we're at our two-step equation. We can't simplify anymore over here. We can't simplify 11. So now you're ready to actually solve it, to show work on both sides to get the a by itself. Let's get rid of the plus 15, minus 15. Bring down that negative 4a, and you got 11 minus 15 is negative 4. To get rid of negative 4 times, divide by negative 4. And what are we getting here? What's negative 4 divided by negative 4? Not 0, just 1. Well, let's plug it back in and see. Let's make sure. I'm not 100% sure we didn't make any mistakes here. So I'm going to use this box again for number 6 to just do our check. Instead of this a, I'm going to put 1. Plus 5, parentheses, 3 minus 1. Does that equal 11? And remember, you don't have to do the distributive property here. You can just do the order of operations and just do 3 minus 1 in parentheses first. So 3 minus 1 is just 2. Keep everything else the same. My multiplying now, 1 plus 10, does that equal 11? Yes, we know 1 plus 10 is definitely 11. That works. So a equals 1 is the solution. That makes the equation true. All right, one last example of something where you could simplify on a side before you have to start solving. Look at this guy right here. We haven't seen an equation where there is a number on the bottom. It's essentially an equation within a fraction. But, guys, we know it's a fraction, but what does that over 11 really mean? It really means divide by 11. So if you need to get rid of some things over here, we don't have any like terms to combine. We don't have any distributive property. This one, we're just looking for a way to start getting that x by itself that's a little bit different than we've done in the past. So the best strategy for this one is to get rid of the dividing by 11 on that whole side. So how do you get rid of dividing by 11? You multiply by 11. So in this case, we are going to start solving the equation right away. If I multiply this whole thing times 11, then the times 11 divided by 11 is what goes away. It doesn't mess with that 6x minus 17. But if I multiply this side by 11, I also have to multiply this side by 11. Do you guys see that? So what would I have, and I'm just going to do the work down here. I know they have all these boxes for us, but what would be left after we did that? 6x minus 17 equals, what's 5 times 11? 55. And then would we know how to solve that? That's just a two-step equation. I'm not going to go through that process because I know you know how to do that already. This one was just interesting because we hadn't seen this trick of multiplying both sides by what was on the bottom there just to get rid of what was on the bottom. So in this case, what could be the first step to produce a simpler equivalent equation? Multiply on both sides by that 11 to get rid of the 11 on the bottom. So that might be a trick that you need to use later on when you see an example like this guy. All right, one last thing, I'm just going to show you guys how this might look when you're writing multi-step equation. So here's where we're going back to the very first page of our notes, not this one, but one more back, called Solving Multi-Step Equations. Let's just look at what it might look like to write a multi-step equation. So this one's fundraising. You're participating in a 15-mile walk-a-thon. You walk and run for the same amount of time. This is something where you'd like collect money, collect donations for doing a walk or a run for charity. So this time you walk and you run for the same amount of time. So if you walked for 5 minutes, you'd run for 5 minutes. You walk at a rate of 4 miles per hour and you run at a rate of 6 miles per hour. How many hours will it take you to complete the walk-a-thon? Well, you know, if you're going 15 miles and you're walking for part of it and you're running for part of it, you're going to get further when you're running, right? Because you're going faster. So we're not going the same distance while we're walking and the same distance while we're running, just the same amount of time. So this is an interesting situation. Look at the kind of verbal model they give us right here. To find out how far you walk, we need to know how many hours we walked times what? What determines how far we get? How fast we're going, right? So this is going to be our walk speed, our walking speed. How fast we're going times how many hours we walk gets us how far we went. So that would be like our miles per hour, right? In this case, your miles per hour running. That's going to be like your running speed times the number of hours that you run. And that's going to give you your total what? The total distance that you go. Okay, there's our total distance. So if we actually put that into numbers now, look at what it would be. Our walking speed times our number of hours. We go 4 miles an hour. We don't know how many hours we walked or ran, though. That's h. But it's the same. We went 4 miles an hour for h hours walking, plus our run speed, 6 miles an hour for h hours running. And h is exactly the same. We walked for 1 hour and ran for 1 hour. We walked for 1.5 hours and ran for 1.5 hours. We know that we walked and ran for the same amount of time. And that's going to be our total distance. How far did we have to go? This was a 15-mile walk-a-thon. We had to get 15 miles right here. That ends up being an equation where we have to do a little bit of simplifying before we can solve, because we can combine some like terms. This is a pretty easy combining like terms. 4h plus 6h's is 10h's. We can't see that very well. Let's try this. 10h's equals the 15 hours. So how do you get the h by itself? Divide both sides by 10. And 15 divided by 10, hey, I even think I said 1.5 here. 15 divided by 10 gives us 1.5. Can you see that on the calculator there? So that would be like 3 halves, or 1.5 hours. So that means for us to go 15 miles, we would have had to walk for 1.5 hours, and we would have had to run for 1.5 hours, and we would have gotten to 15 miles. And we could plug that in to see. 4 times 1.5 plus 6 times 1.5, is it going to give us 15? So this is just an example. I'm going to put hours right here just to finish up the problem. That's an example of what it might look like when you're writing a multi-step equation from a given situation. So I'm going to give you guys some practice time to do some multi-step equations with combining like terms and the distributive property.